Hello, 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 and welcome back to Shiksha DaCosta. Today we're going to be learning about experimental probability. So today we're learning about experimental probability, and you know that you're good at this when you can perform something called a probability experiment, and you can represent the results using a frequency distribution. And then when you can use that distribution to determine what is the experimental probability of an event. So to get our minds activated and thinking about things in the right way, what are the chances of rolling a 4 when you roll a single D4? Well, I think that there's 4 different outcomes, and 4 is just one of those 4 outcomes. So I would say 1 out of 4, there's a 1 out of 4 chance, which is about 25%. And then I'd like you to pause the video and answer this question here. If you roll this dice 4 times, how many times would you expect to get each of the different results? 1, a 2, a 3, and a 4. Hopefully you were able to realize that, hey, if there's a 25% chance I'll get a 4, then if I roll it 4 times, then probably 25% of the time I will actually get a 4, which is 1 out of those 4 rolls. And if I roll it 4 times, another one of those 4 will probably be a 3. And a 2 will have the same chance. 25% of the time I'll probably get a 2, so 1 out of 4. And then 25% of the time I would get a 1. Now, you might be thinking to yourself, hold on. Couldn't I roll this? I'm just randomly rolling this dice. Couldn't I get a 4 like 3 times? Yes, technically that's true. But we're not looking at We're not looking yet at what has actually happened. We're just trying to predict what is the best guess for what could happen. And if you were rolling this dice 4 times, there's only a 25% chance of getting a 4, which means that you'll probably only get a 4 once. But now let's see this probability, actually in action. What we'd be doing when we actually roll the dice is performing a probability experiment. So in this investigation, what you're going to try to do is roll 3d4, and you're going to do this 10 times. I'll give you a link where you can absolutely scan it with your phone, and that way you can go right into a web page where you can roll 3d4 very easily, and it'll give you the result very easily. But before we do that, I'm just going to show you an example of how this investigation is supposed to go. So in this investigation, you're going to roll 3d4. You're going to do it 10 times, and you're going to write your results maybe in the first row here. And then you're going to write the percentage of rolls that match that result in each row. So in this row, we've rolled the dice 10 times. That's why they're both in green. And we're going to write how many times what percent of our results were the number 3? What percent of our results were the number 4? And so on. So suppose, I'm just going to do this for, just by myself first. Suppose I rolled this 3d4. I did it 10 times. The first time I got a 6. Then I got a 7. Then I got an 8. Then I got a 9. Then I got an 8. Then an 8. Then a 6. Then an 11. Then a 7. Then a 12. Which we know is really, really difficult to get. I would have to get 3 4s. But I did get it this time. What percent of my rolls were a 3? Think about that for just a second. What percent of my rolls were a 3? Well, looking at my roll results, 0 out of 10 were a 3. So 0 divided by 10 is 0%. And the same thing, I don't see any 4s. 0% of my results were a 4. 0% were a 5. But I did roll a 6, didn't I? In fact, I rolled a 6 2 times. And 2 out of my 10 rolls, 2 divided by 10 would be 0.2, or 20%, if I multiply that by 100. Moving on, how many of my rolls were what percent of my rolls got a 7? Again, 1 and 2, 2 out of 10 is 20%. What percent of my rolls were an 8? I can see here that I've got 3 8s, and 3 out of 10 would be 30%. How many 9s? What percentage of my rolls were 9s? Just 1 out of 10, and so that would be 10%. How many 10s? 0% of my rolls were 10s. I never rolled a 10. 10% of my rolls were an 11, 1 out of 10, and 10%. In 10% of my rolls, I got a 12. Okay, 1 out of 10 again. And then what you're going to do, this is not the entire investigation, you're going to actually roll the dice 10 more times. And then you're going to fill out the next row. And this time, in total, we would have 20 rolls of the dice. And then we will redo this row for 20 rolls. So, suppose I rolled the dice 10 more times, and this is what I got. What percent of my rolls now were a 3? Think about this for just a second. Well, just like before, I never rolled a 3, so that would be 0%. But now I started to roll a 4, didn't I? I have 1 4. So what percent of my rolls were the result of 4? Hopefully you were able to think about that for just a bit and come up with the same number I got, which is 5%. Notice that there's a single 4. So 1 out of, but now we're not counting just this row, we're counting 20 rolls. We're including the rolls that we made before. So 1 out of 20 is 0.05, which is 5%. 5% of our rolls were now a 4. And similarly, we'll keep going, right? How many of my rolls were a 5? 15%. 1, 2, 3 out of 20. 3 out of 20 is 15%. A 6. Notice that my number 6 has actually changed. It used to be 20% because I rolled it 2 times out of 10, but now I only rolled it 1 more time. So now I have 1, 2, 3 out of 20, which is 15%. So my percentage actually went down. And the reason for that is because I'm dividing by a bigger number, but my numerator did not increase as much as it did before. It did not go to 4 out of 20. It's now just 3 out of 20. Think about the number 7 now. How many rolls, what percentage of my rolls were 7? It used to be 20%. 2 out of my 10 rolls were a 7. But now that I tried this experiment one more, I added 10 more trials to my experiment, I found that, actually 7 does not come nearly as often as we did when we came up, when we only did 10 rolls. The 7s, even there's still 2 7s, but now it's out of a larger number. So 2 out of 20 would just be 10%. So 7s don't seem to be coming up as often when we did 20 rolls. What percent of my rolls were an 8? There are 1, 2, 3, 4 8s, which would be a total of 20%. 4 out of 20 is 20%. How many 9s are there? 1, 2, 3, 4. Again, 20%. 4 out of 20. How many 10s are there? Well, there used to be 0% of my rolls were a 10. So if I took just the results from this experiment, rolling it 10 times, I would say, you're never going to roll a 10. Because there's a 0% chance. I've calculated the probability based on my experiment. But if I make my experiment happen more often, if I roll it 20 times, if I do 20 trials instead of 10, I find out, hey, hold on, this time 1 out of 20 or 5% of my rolls actually were a 10. So it is possible. If I rolled it 20 times, how many 11s did I get? Well, it used to be 10% of my rolls. So I thought, okay, I would probably keep getting an 11 10% of the time. But now I realize, hold on, now it's just 5% of the time. And the same with 12. Its proportion of all of my rolls drops from 10 to 5. So this is what you're going to do in this experiment. Okay, I've walked through the first 2 rows for you. You're going to keep going for all of these rows here. You're going to repeat this for 30 rolls, 40 rolls, 50 rolls until you reach 100 rolls. And this will take you quite a bit of time. So take as much time as you need to complete this experiment. And then once you're done, you can go ahead and continue the video and we will take it up afterwards. Here is a clean sheet that if you would like to copy down these charts or even just take a screenshot and use your computer to fill it out, you can use this QR code to scan and which will take you to a link where you can actually roll 3 4-sided dice. And you would do that again 10 times, fill out the first row, and then calculate your percentages. Another 10 times, fill out the next row, calculate percentages, and so on until you are done the entire investigation. Experimental probability is the likelihood that an event will happen, and we determine this by how often that event has already happened. You can conduct any sort of probability experiment to ascertain, to figure out what is the frequency of each outcome, and then use that to calculate how probable it will actually happen in the future based on that data. And some probability experiments include, rolling a dice, using a spinner, picking balls out of a bag that have like numbers or words on them, randomly choosing an outcome. If you increase the number of trials in your experiment, that will obviously increase the accuracy of the results. And this is the same way as if you have studied one variable data. When you increase the size of a sample, that helps it represent the population better and better. And so increasing the number of trials is sort of like making your sample size bigger. Finally, experimental probability is extremely useful because not all situations have a theoretical probability that we can easily calculate. And so for those situations, we want to rely on experimental probability. You might be thinking, is there a point in time when increasing the number of trials actually makes it less accurate? And no. In fact, one of the things that people will do is they will create a probability experiment not by rolling dice, but they will actually use a spreadsheet. And I have done this in the past. There is a function on a spreadsheet called rand between, which randomly chooses a number between two numbers that you specify. And so I'll choose rand between 1 and 6, and that's the same thing as rolling a 6-sided dice. And I can have that formula fill out 1,000,000 different cells in my spreadsheet. And that's the same thing as rolling a dice 1,000,000 times. And that way I don't actually have to do it myself 1,000,000 times, but I will see from rolling it 1,000,000 times, the experimental probability gets more and more accurate the closer we get to that high number. Just for an example here, in the trading card game Magic the Gathering, it's a very popular game, it's been around for many, many years. These cards, they sort of look like this. They contain special rules that interact with the main game rules. Some cards offer some rules that are so powerful that offer you so many benefits and abilities, and some cards can actually be used in combination with other cards to make them even more powerful. These are how trading card games actually work. If you ever watched the show Yu-Gi-Oh, or there's even Pokemon cards. Trading card games work like this, where each card has a different set of rules that contribute and interact with the main game rules, and some cards are obviously better than others. In a recent tournament, the decks that players used, the decks that contain the Black Lotus card, actually won 85 games and lost just 15. What is the probability that you will win if you are facing a deck that contains Black Lotus? So out of the total number of games that this player played, if we add up 85 and 15, the decks that contain the Black Lotus card played a total of 100 games. And out of those, they only lost 15. And so 15 out of 100 would give us 0.15. or 15%. So based on the data that's available and not based on anything else, the experimental probability that you will lose or that you will win is just 15%. If you like this video, please like, rate, subscribe, and join our mailing list. And you can find this lesson as well as practice questions, solutions, handouts, and more on our storefront. Thanks and have a great day.